Hello, my name is Andrew Ohm. I'm a member of the Hope College Alumni Board of Directors, and I'm here in sunny Seattle, Washington, at the University of Washington School of Medicine to celebrate Dr. Deborah Heydenburg Fuller, a graduate from the year 1987, and we are here to present her today with the Hope College Distinguished Alumni Award. Vaccine. A word that may have held little meaning to some people in recent years has suddenly become a word filled with so much possibility and hope. While most ignored or took for granted the presence of medicinal viral prevention, Dr. Deborah Fuller was dedicating her life and career to developing new and innovative vaccines, antivirals, and methods to distribute them safely and effectively. Dr. Fuller studied biology, Spanish, and mathematics at Hope College, where she participated in the renowned student research program, graduating in 1987. She initially worked in biotechnology and became a senior scientist developing vaccines against HIV, HBV, and other emerging infectious diseases, and co-inventing nucleic acid vaccine strategies she still employs in her research. In 2001, she earned a doctorate of philosophy in molecular and cellular pathology and transitioned to academia in 2004. She is currently serving as a professor in the Department of Microbiology at the University of Washington School of Medicine and is chief of the Infectious Diseases and Translational Medicine Division at the Washington National Primate Research Center. She leads a team developing and optimizing nucleic acid vaccine technologies and has led the translation of 2 vaccines from bench to clinical trials, including the first DNA vaccine to induce protective levels of immunity in humans. She has authored 90 manuscripts and book chapters and is a co-inventor on over a dozen patents for vaccines and antivirals. Dr. Fuller is also the founder of biotechnology company Orlance Incorporated, which aims to advance nucleic acid vaccines for infectious diseases and cancer. A needle-free device to deliver vaccines into the skin has also been the focus for her work through Orlance. During the recent pandemic, Dr. Fuller has played a key role in the advancement of vaccines and antivirals for the prevention and treatment of COVID-19. Her lab has developed a second-generation nucleic acid vaccine for COVID-19 that entered human clinical trials in spring 2021 with the future hope of worldwide distribution. She has also played a key role as an expert to inform the community and public of the science behind the COVID-19 vaccines, having been featured on Bloomberg TV, CNN, and NPR, and having contributed to articles from the Washington Post, the Associated Press, the Wall Street Journal, and several others. Her op-ed articles have been read by millions worldwide. She also presented an incredibly informative and popular webinar exclusively for Hope College alumni as part of Alumni Weekend 2021. We are thankful for Dr. Fuller's role in protecting and healing the global community from infectious diseases and for her ability to effectively communicate the importance of and science behind these vaccines. We are proud to have her as part of our Hope College alumni community and honored to name her a Distinguished Alumni Award recipient of 2021.
Well, hi, Dr. Fuller. It's an honor to be with you. We're so proud at Hope to have one of our graduates working on literally the most important thing that the world is going through right now. Before we talk about what you're working on now, I'd love to start by reflecting back specifically on your time at Hope as a student. What do you remember from your time at Hope, and what transformational experiences happened at Hope that helped put you on the career path that you've been on?
Yeah, the most important thing that happened to me at Hope was the discovery of love for scientific research. And I would have never thought of going down that path had Dr. Gentile, who's my
Yes.
mentor in the Department of Biology, not given me a chance to come into his lab and experience what it's like to do research, to ask questions and form hypotheses. My goal was originally to actually become a physician. I came to Hope as a pre-med, and I just got fascinated by genetics in one of his classes and learned that he was doing research, and I stood at his door as a sophomore, and I said, could I do research in your lab? And normally he didn't take sophomores. He waited till they were juniors or seniors, but he let me in the door, and the first experiments that I did were complete disasters, but I fell in love with the whole process, and that is really what put me on the path to what I am today.
Wow. It's great to hear that research still is one of our hallmarks, and we're proud to be a relatively small school, but a school that really focuses on student research and specifically students working with our faculty scholars, much like you had that experience with Dr. Gentile. Do you remember what research you were working on? Do you remember?
Yes, I do. I can't forget that. It was actually, Dr. Gentile had a research program investigating how plants metabolized herbicides into potential mutagens that could cause potentially cancer. And I mean, it was really actually cutting edge research. And that's what was amazing, is that here's a small liberal arts college in Holland, Michigan, doing this really cutting edge research. In the 1980s, it was not common for undergraduates to do research like that at that level. And Hope College was unique and a standout in that regard.
So even back in college, you were working to cure human disease.
Exactly. I mean, that's really got my start.
What other memories, maybe co-curricular or extracurricular activities, were you involved in, and what do you remember from your 4 years at Hope College?
Yeah, I love the sport. So my freshman year, I joined the Hope College cross country team under Coach Vanderbilt. And one of my most delightful memories is that he would drive this big blue and orange bus around to bring us to different places to go run. So cross country could be boring, where you just, everybody just go run around the same streets and the same pathways, around the college or whatever. But instead, he made it interesting and exciting. But what it did was it also built a camaraderie in the team, because that bus ride there and the bus ride back was a great experience.
You got to know each other.
Yeah, exactly. And
on the blue and orange bus.
Yeah, on the blue and orange bus.
What a great memory. What a great memory. Obviously, you were very involved with research and with the biology department, but you also would have taken history classes and religion classes and classes in other areas, which is the hallmark of liberal arts, this wide aperture of knowledge. Talk to me a little bit about how the liberal arts contributed to your success today.
Yeah, I think a lot of students, when they go into the science and say, hey, I want to be a physician or I want to be a scientist, they think of, well, what I really need to care about is just the sciences, the math, the biology, and things like that. And what really is important is that liberal arts education, the ability to learn how to communicate your ideas. And that really comes from that broader liberal arts education. Every day I have to communicate our findings in research. Right. I had to convince people to give me funding. You can be the smartest person in the world and have the best idea in science, but if you can't communicate, nobody's going to give you money to do it, right? The whole broader liberal arts education has played such an important role. And I see this even in students who come and work in my lab as graduate students. Those who had a really strong liberal arts education tend to actually excel much more quickly than those who don't.
I love that. I love hearing that. Let's talk a little bit about your work today and what you're working on. It's I imagine it's interesting for you because you've spent your life working on vaccines, and now all of a sudden everyone in the world is talking about vaccines. Talk to me a little bit about what that feels like to all of a sudden have your area of expertise be the thing that the world is talking about.
I have been working on this all my life. For 30 years now. I've been working on vaccines, and so it's been my passion, and it's been foremost in my mind, of course, all this time. And now to see, everybody recognize the importance of that, it's really quite exciting. And really, the COVID-19, I know that the vaccines have really been transformative for COVID-19, but COVID-19 actually transformed vaccine field as well. And we're never going to be the same. We're always going to look back on this time as the pre-COVID and the post-COVID and all the amazing things we were able to do in such a short period of time, working together with other scientists in a very open way that we had never done before to solve a common problem. And so while the vaccine area is all exciting for me, I've been working on it my life. What's even more exciting is how the scientific world got together to solve this problem together, and in the process has started, I think, a whole new revolution, if you will, or renaissance in science that new students graduating now are going to reap the benefits of for many years to come.
If you flash back, say 15 months ago, this area, the Seattle area, was one of the first epicenters of COVID-19 in the United States. And if you think back to that time and then compare where we are today, what takeaways have you learned, or what has surprised you from the last 15 months?
Prior to COVID-19, the fastest vaccine ever to be developed took 4 years to do.
4 years.
Yeah.
Wow.
And that's just based on how vaccines were developed. We would have to do things very sequentially. We would have to wait until, say, research was published before we could build on other people's work. Now, we were working at the time with the RNA and the DNA vaccines that ended up, being the success stories.
Right.
And I always knew that they would be the type of vaccine to make it first across the finish line if there ever was a pandemic. In fact, most of my grants, I would always write, you got to fund me because one day we're going to have a pandemic and we're going to need to solve this problem. And this is the way to do it because these types of vaccines don't take as long to develop. We knew that. We got started right away in January when the sequence of the virus got published. We were able to get started. We made a vaccine within a week that we were already testing.
Wow.
So it's that
January 2020.
January
Wow.
2020. We were not waiting for the traditional peer review process, but just putting that online because we knew that other people could learn from what we just learned and then take it from there. And it was really this cooperation and collaboration among scientists worldwide that was able to bring this vaccines and the solution within a year.
Amazing.
Yeah. So I would have never predicted that just simply because that's not how we used to operate. But COVID-19 made a big change for us. Yeah.
Wow. And talk to me about what are you working on today, or what are the big things that are front of mind for you today as you think about the future?
Absolutely. So we're still working on COVID-19 vaccines because as long as there's virus replicating in the world somewhere, there's still going to be new variants that pop up and a potential threat to reducing the efficacy of our current vaccines. And so we're working on updating and testing new second and even third generation vaccines. Worldwide, the vaccination rate is very low. It's around 5 to 6% right now. So there's areas in the world that don't have vaccines, and our goal right now is try to develop new vaccines that are going to be able to be more effectively distributed worldwide to be able to bring immunity throughout the world and shut this down together.
Just talk to me a little bit about what it looks and feels like in your lab. What's your team like?
Yeah, I have about 20 researchers in my lab. I have a couple graduate students, 2 postdocs, what we call junior faculty, they're assistant professors. I have a number of technicians, and importantly, I have undergraduate researchers. That's the thing I learned from Hope is that the importance of starting early as an undergraduate in research. And I don't have to take undergraduate researchers, but that was something that in my lessons at Hope that I felt that was something important that I wanted to carry forward in my own career.
Oh, Dr. Fuller, that's beautiful. It comes full circle back to exactly the experience you had with Dr. Gentile, and you're now doing that for undergraduates right here.
You bet.
That's amazing. That's amazing. And they will, for the rest of their lives, get to say that they worked with you during the pandemic on vaccines. That's pretty remarkable.
That's something I tell people. Our goal is to never have another pandemic again. That's my career goal, is to get to the point where we have vaccines and capabilities to stop a new outbreak before it ever causes a pandemic again.
Well, Dr. Fuller, we are so proud of you and all the work that you are doing. And so on behalf of Hope College, it's my honor to present to you the 2021 Distinguished Alumni Award.
Oh, thank you. This is such a wonderful honor. Oh my gosh. It's just, this is something I'll hold in pride for many years to come. Yes.